Okay, so this is the last of our day one balancing equations videos. So this is how to predict products. So predicting products becomes necessary when you are only giving reactants, obviously, and you have to predict the products. We already know all of our ionic charges, whether they are from our representative elements, our transition metals, or our polyatomic ions. And so if you can identify what the charges are, you should be able to figure out what your new products are going to be based on what the things are starting off as. Are they compounds and they're swapping like a double replacement, or do we have a single replacement, or do I have a synthesis going on? You should be able to kind of figure out what's going on through here in terms of how will my products come together. So first of all, you're going to identify your reacting particles. Do I have ionic compounds, or do I have the ingredients for a combustion? Okay, so ionic compounds are basically anything on the periodic table: metal, nonmetal, metal, polyatomic ion. Combustion reactants would be your carbon and your hydrogen. Remember CY or CXHY, where their X and Y represent your subscripts. It could be anything, plus oxygen. If I have combustion reaction, I don't have to predict products. I already know what they are. I only have to predict products if it's an ionic compound. What I do need to do with a combustion reaction is recognize, oh, wait, look, that's combustion. I already know what it is. You have to recognize it to be able to take advantage of the fact that you already know what it is. So 2A, if it's ionic, take it apart into its individual ions, combine your positive and negatives into your new substances. Remember, positives come first. If it's combustion, write carbon dioxide and water as your products and move on to balancing. It's actually easier if you have combustion because you don't have to predict and deal with charges. You just write down CO2 and H2O and move on. And then you balance the equation, just like normal. All right, so we're going to go through 3 examples, and it's not everything that you'd possibly see, but it's enough that you can use the skills I'm going to show you to figure out any sort of predicting products problem. Okay, so here's our first one: NaOH or NH4OH plus CaCl2. So what is this? Is this ionic compounds or combustion? Well, I don't see any carbon, hydrogen, and oxygen. So this, I'm assuming we're dealing with ionic compounds. All right. So I'm going to look at these and take them apart in their ions. So what ion do I see first? Well, I've got 2 polyatomic ions hanging out together. NH4 plus 1 and OH minus 1. Then I'm going to take these apart. I've got Ca plus 2. I've got Cl minus 1. All right, so let's deal with this issue right off the jump. This 2. This 2 is here because we dropped and swapped when we were paired with calcium. But we're about to not be paired with calcium anymore because we are going to rearrange these ions. This 2 does not come with the chlorine, all right? It's there because of a drop and swap. It's going to drop and swap with something new. We're going to take care of this 2 when we balance and add coefficients. That's different from this 4. This 4 goes with me. Why? Because that's a polyatomic ion. That 4 is part of the ion. So if it's a subscript that's part of a polyatomic, it goes with you. If it's a subscript that's there because of a drop and swap, ignore it until you go back and balance. Okay? All right, so if it's ionic, take it apart into its individual ions. We just did that. Combine positive and negatives into new substance. Remember, positives first. So recombine. I'm going to flip these around. So the NH4 is going to pair up with the Cl, and the Ca is going to pair up with the OH. I'm going to write the positives first in both cases. It doesn't matter if I write the NH4Cl first or if I write the Ca with the OH first. That does not matter. But the individual parts have to be balanced right. So let's do the NH4 and the Cl. So NH4 plus 1 and Cl minus 1. I don't need to drop and swap there. So NH4Cl is my new substance. Plus, what's my other substance? Ca plus 2 and OH minus 1. I do need to drop and swap there. So Ca plus 2, I'm going to have 2 OHs, and that's polyatomic, so it's got to go in parentheses. CaOH 2. All right, so Now I can deal with my balancing. So I'm going to rewrite this since I kind of wrote all over this just to make it easier to see. NH4OH plus CaCl2 yields NH4Cl plus CaOH2. And we're going to do this without a chart because this is the third balancing video, and I think by now that we can start to see some of these without having to write the chart. So I have one NH4, one NH4, one OH, two OHs, one Ca, one Ca, two Cls, one Cl. So I need more OH on this side and more Cl on this side. So I'm going to put a 2 in front of the NH4OH. That's going to give me two OHs. I'm going to put a 2 in front of the NH4Cl on that side. That's going to give me two Cls. And then it also gives me two NH4s and two NH4s. So I'm good. All right. Now I need to turn that into words. I need to write a lovely word sentence with my proper nomenclature. Your nomenclature piece has to be exactly what it should be, but your joining words, you have a little bit of flexibility. Pick whichever ones you like. If you want to say plus, say plus. If you want to say and, say and. If you want to say combines with, knock yourself out. Makes, produces, yields, forms, pick your verb. I like to use the ones that are short because it makes my life easier. So you do you, but make sure your nomenclature piece is right because that's what I'm grading you on. All right, so the first one, can't just use the plus signs. NH4OH, that's ammonium hydroxide plus, or plus doesn't have an E, or and, whichever word you like, CaCl2, calcium chloride, produces, makes, produces, yields, forms, whichever verb you like. What am I making? Ammonium chloride. And calcium hydroxide. Period. Done. If you are good at your nomenclature, this is easy, right? All you're doing is reading it off. You already say what they are. Write it down. Okay. Let's look at another example. Oh, what type of reaction is that? Hold on, I almost forgot one of the most important parts. Compound, 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 compound. Na was with OH, or NH4 was with OH. Now the OH is with Ca. Yeah, this is double replacement. Okay. Next one. Al plus Fe2O3. All right. So aluminum to start with is by itself. I obviously know it's going to pair with something else, so I just write down what the charge of the single element is. Fe and O3. Well, what do I know about Fe? It's a transition metal. I need to reinvent that charge by looking at what it's paired with. We already know how to do that. So I look at oxygen. Oxygen has a charge of -2. There's 3 of them, so -6. The iron's going to be +6, but there's 2 of them, so each one's +3. So this is iron 3. Okay. So recombine my positives and my negatives. The aluminum is positive. It's going to have to pair with the oxygen that's negative. Then what's going to happen to the iron? It's going to get booted out and be by itself. So Al plus 3 and O minus 2, drop and swap, Al2O3 plus Fe. Okay, now let's take care of our balancing. So Al plus Fe2O3 yields Al2O3 plus Fe. All right, so I've got one aluminum, two aluminums. So let's put a 2 here. Let's see, 2 irons, 1 iron. Let's put a 2 here. 3 oxygens, 3 oxygens. Looking good. All right, now let's name this thing. Aluminum's by itself, so I just call it aluminum. All right, aluminum plus, we determined which iron was this, iron 3. So iron 3 oxide yields aluminum oxide, yeah, plus iron. Now, you could put plus iron 3, and that's fine, or you can just put plus iron. It's by itself. At that point, the charge really doesn't matter. We need to know what it is here, because that informs us of what the charge is to the drop and swap for the balancing. But if you want to leave it as iron when it's by itself, that's fine. Iron 3 by itself, also fine. I will take it either way. All right, last one. Dun, dun, dun. Of course, it's combustion. Daggone, this is single replacement. Slipping. Okay, of course this has to be combustion. I got to give you an example of combustion. So, first thing I need to do is I need to recognize this is in fact combustion. I've got a carbon-hydrogen compound. I have oxygen. Oxygen is diatomic. I don't have to predict products. Say it with me, friends. You don't have to predict products. You already know what they are. If you tried to predict products here, you would get some sort of hot mess. Okay? Don't try to predict products. Just write down what they are. Anytime I'm going to burn something that has C's and H's, I'm going to make carbon dioxide and I'm going to make water, and that's it. You just have to write it down. Okay? Do not try to predict some sort of crazy products here. All right. So I would not ever recommend doing any sort of balancing with a combustion problem without a chart. So we're going to scratch out a real quick chart to balance this guy. All right, so inventory. 2, 6, 2, always 1, 2, 3, 2 carbons, 2 in front of the carbon dioxide, 6 hydrogens, 3 in front of the water, that's going to make 6. 2 times 2 is 4, plus 3 is 7. Nothing times 2, that's a whole number, is going to give me 7. So what do? Double it all. 2 here, makes this 4, makes this 12. This becomes a 4. This becomes a 6. So that's a 4 carbon, 12 hydrogens. 4 times 2 is 8, plus 6 is 14, and 7 times 2 is 14. Okay. In terms of the naming here, I'm going to have to give you what these organics are. I don't expect you to know them. I do expect you to know the rest of this because we've done it. But I am going to have to give this to you. So for any of the ones where you have a combustion, you'll be provided a list of the organic compounds. C2H6 is ethane. So this is ethane plus oxygen. Yields, produces, makes, forms, whichever verb you like. Carbon dioxide. And dihydrogen monoxide. Do not be lazy and say water. I will mark it wrong. It is dihydrogen monoxide. Okay, those are your processes that you follow for predicting products. Go forth, balance equations.